In this video, we'll take a look at the equation for a circle. We're going to start with the distance between 2 points, 0, 0, and 3, 4. This might seem weird since we're talking about circles, but it will make sense in the end. So to find the distance between 2 points, there is a distance formula, but it's based on Pythagorean theorem. So let's go ahead and make a right triangle, and I'm going to call the hypotenuse r. So Pythagorean theorem gives us 3 squared plus 4 squared equals r squared. If we work this out, we end up with 25 equals r squared, so r is equal to 5. Let's try this again with the points 0, 0 again, but this time going to negative 4, 3. Let's draw our right triangle. And it turns out this is going to be the same exact equation because we have legs of 3 and 4, so our hypotenuse will again be 5. So there's other points we can find that make 3, 4, 5 triangles so that the distance from the red point to the green point would be 5. So if 3, 4 worked, so did 4, 3. So did 4, negative 3. Do you see the other ones that are going to work? We've got 3, negative 4. We got negative 3, negative 4, negative 4, negative 3, negative 4, positive 3, and negative 3, positive 4. I don't like my accuracy on that negative 3, positive 4. It's kind of difficult to get these in the right spot. Let's fix that. There, that looks better. So what other points would work that would be 5 units away from 0, 0? We could have actually started with these. These are the easiest ones to find. How about 5, 0? That's 5 spaces from 0, 0. Another one would be 0, negative 5. You like my accuracy on that one? Let's try that again. Oh, still not good. Let's try it again. Oh, a double point. Man, I'm struggling trying to get these points in the right spot. You ever played that game at like Chuck E. Cheese? I think it's called like the claw machine. Looks like this. Yeah, that's kind of how I'm feeling trying to get these points right. Let's try it one last time. There we go. All right. What else works? You could have negative 5, 0, and 0, positive 5. So now the question is, what do we get when we put all these points together? Well, it's kind of hard to keep this a surprise when I give you the title to the video. When you connect all these, they would form a perfect circle. All right, let's clear out a space and see if we can come up with an equation for this. Let's look at the very first right triangle that we made. Let's go ahead and label the x value, that leg, x, and then we'll do the vertical leg will be y. And then if we write Pythagorean theorem, we get x squared plus y squared equals r squared. So this is the easiest equation for a circle. But this circle always has a center of 0, 0. Let's go ahead and test it out on one of the points that we found. Let's try negative 3, negative 4 that I circled there. So if we plug this in, does negative 3 squared plus negative 4 squared equal 5 squared? Yeah, 9 plus 16 is 25, so it works with the formula. What if we want to test another point, like if x equals 2? There's the point. What would the y value be? You just have to put it into the equation. So 2 squared plus y squared is going to equal 5 squared. If we work this out, we end up with y squared equals 21. So y has a value of radical 21, which if you put in the calculator is 4.583, which looks like the y value on our graph. All right, let's go ahead and make sure you've got this idea. What if I give you this circle? Can you write the equation of this circle? All right, so the center is 0, 0. The radius is 4. So our equation would simply be x squared plus y squared equals 4 squared, which simplifies to x squared plus y squared equals 16. How about this circle? We still have a center of 0, 0. This time the radius is 7. So we would write x squared plus y squared equals 7 squared, which simplifies to x squared plus y squared equals 49. Now, another way that we could write this equation is if I divide every term by 49, we're left with x squared divided by 49 plus y squared divided by 49 equals 1. Now this is a more complicated looking formula, But this will help you a lot when you get to more advanced math and you start making shapes that aren't circles. All right, let's go back to our original circle. X squared plus y squared equals 25. And now let's take a look at what happens when I make a new circle that is shifted 3 spaces to the right. So now the center is 3, 0, and the radius is 5. So let's take a point on the end there. We have a point 8, 0 is on our new orange circle. If we plug that point 8, 0 into our x squared plus y squared equals 25, 8 squared plus 0 squared, it doesn't equal 5 squared. So the question is, what would we do to the 8 so that it would work in our formula? If we go 8 minus 3 and then square it, now it works. Now notice the relationship. The 3 matches up with the center of 3, 0. So if we want to write the equation of the orange circle, it's x minus 3 squared plus y squared equals 25. Let's go ahead and make sure that it works. It looks like the point 6, negative 4 is on our orange circle. Let's plug it into our formula. If we have 6 minus 3 squared, that would become a 3 squared. And then our negative 4 squared, that would become 16. And we get 9 plus 16 equals 25, and it works out. Okay, let's go back to our original circle. This time I'm going to make a new circle that's 2 units below our original. So now our center is at 0, negative 2. Our radius is still 5. So this gives us a point 0, negative 7 that shows up on the circle. But if I put that into my formula, 0 plus negative 7 squared, it doesn't equal 5 squared. So what do we have to do to our negative 7 to make this equation work? If we add 2, then we get negative 7 plus 2, which is negative 5, and then that would simplify to negative 5 squared, which is the same thing as 5 squared. Another way to write that, negative 7 plus 2, would be negative 7 minus negative 2. When I write it this way, you can see that the negative 2 in the formula matches the negative 2 in our center. I'm going to go ahead and write it though. X squared plus y plus 2 squared equals 25. So take a look at how we have a center value of negative 2 for the y, but in our formula we put a positive 2. So what happens here, what I like to always think of, you always take the x or y value of your center and use the opposite in your formula. Let's take a look at what will work for any value. Let's say our center is hk and our radius is r. Our formula for this circle will be x minus h squared plus y minus k squared equals r squared. Let's try it out. What if I know the center is 4, 2 and the radius is 3? How do I write the equation? I just plug in the 4 and the 2 for the h and the k, and I get x minus 4 squared plus y minus 2 squared equals 3 squared for my radius part will equal 9. If we graph it, we'd put a point at our center of 4, 2, and there's our circle with a radius of 3. Or you can always use the more advanced version, which will help you later in math, of x minus 4 squared over 9 plus y minus 2 squared over 9 equals 1. Let's try another one. Center is negative 1, negative 3, radius is 6. All right, let's draw our circle first on this one. Our center is at negative 1, negative 3, and there's our circle with a radius of 6. By the way, just so you know, the center of a circle is technically not part of the circle. It's there only as a reference. It's an important reference that we need, though, to write the equation. So our equation is going to be x plus 1 squared plus y plus 3 squared equals 36. We've taken the opposite of the negative 1 and put plus 1 in the parentheses for x, and the opposite of negative 3, put plus 3 in the parentheses for y. And then we squared our 6 to get 36. And here's the other version. All right, what if I give you the picture of the circle? Can you write down the center, the radius, and the equation? So this center is -5, +6, and our radius is 4. So our equation is going to be x plus 5 squared plus y minus 6 squared equals 16. All right, what if I give you some different information? I give you the center is 4, -2, and I tell you that the area is 25 pi. How can you figure out the radius from this? Well, we have to know that the area formula is pi r squared. So I can write that pi r squared equals 25 pi, and then I have to solve for the radius. Divide both sides by pi, you get r squared equals 25, so r equals 5. So now I can draw my circle with our center at 4, -2, and a radius of 5. So our equation is going to be x minus 4 squared plus y plus 2 squared equals 25. Time for some practice problems. When you see the problem, pause the video and give it a try. Then hit play to check your answer. So on this one, our center is -2, 1. Our radius is 7. And that's all the information we need to write our equation of x plus 2 squared over 49 plus y minus 1 squared over 49 equals 1. It doesn't matter which form you use. I'm going to show this form every once in a while so you don't forget it. Although most of you guys will probably write x plus 2 squared plus y minus 1 squared equals 49. Okay, in this problem, you're going to write it in standard form, which means not like what I just did. And you got two problems here. So the first one, you should have gotten x minus 8 squared plus y plus 5 squared equals 144. Second one is x plus 7 squared plus y squared equals 81. You could write in parentheses y minus 0, but it's unnecessary. If the x or y value of your center is a 0, then you can just write x squared or y squared. All right, last problem. All right, so this time you're going to have to start with the circumference formula. Circumference is 2 pi r, so that means 2 pi r equals 26 pi. Divide both sides by 2 pi, and our radius is 13. So now I have my center and my radius, and I can write my equation. X minus 7 squared plus y plus 11 squared equals 169.
Bonus round.
Okay, so this is our standard form. I'm going to add a little thing here and show you what's called the general form. If we take this form and start working it out, expanding it, we get x squared plus 4x plus 4 plus y squared plus 6x plus 9 equals 16, and then rearrange the order and put the x squareds and the y squareds at the start, and then the last step is to set it equal to 0. This is what's called the general form of the equation of a circle. It's not very useful to graph because you can't easily figure out the center or the radius. But often what happens is you will be given this form and have to convert it to standard form. So let's go ahead and take a look at how that works. All right, I know I'm going to run out of space here, so I'm going to cut into this graph a little bit. We're going to complete the square for both the x part and the y part. So I'm going to group the x part together, x squared minus 8x, and leave a space to complete the square, and do the same thing for y's. So to complete the square with x squared minus 8x, I'd have to do a plus 16. That means I'd have to add 16 to the right side of the equation. And then with the y squared plus 2y, I can divide that by 2 and square it to add 1 to complete the square. You also might make a generic rectangle off to the side for these to figure out what you need to do to complete the square. So the plus 1 goes on the other side. And now when I simplify, the x part becomes x minus 4 squared. The y part becomes y plus 1 squared. And it all adds up to 36. Now we have standard form, and from this we can easily figure out that our center is 4, -1, and our radius is 6. And now we can use that information to graph it. And there's our final graph.